Alrighty, let's begin. Let's have a look at these. Now, it's okay to be wrong. Okay, in fact, I strongly encourage you not to erase your mistakes and simply put down the correct answer. And then you can learn from that mistake. Okay, it's not about getting it right; it's about learning it, how to do it. Exactly. So let's give it a whirl here. A ball is thrown up in the air. It lands on the ground at your feet 10 seconds later. Position is measured in the vertical plane. In other words, I'm measuring the height. Okay, so first of all, I can assume that everything is above 0. Because there's no such thing as, well, I guess there is, right?
If you throw the ball hard enough to the ground, it'll go in the ground.
I guess if there was a hole, or maybe if you were at the edge of a cliff, right? But it doesn't say any of that, so it's just plain old ground. The ball is, phones away, you guys. Phones upside down. This is the pay attention phase. Mom can deal without you for 30 seconds. All right, let's talk about this. So the ball is thrown up into the air. We're measuring the height, right? So the height, the displacement goes up, right? What about the shape? Is it, you got two options. In blue, is it like this? Or is it in red, is it more like that? Which one do you think? How many people say red?
Doesn't go straight up and down. It goes like a curve.
How many people say blue? Anyone? You're just saying that, aren't you? Yeah, you're right. It's the red one. It's curved. How come it's curved? Remember yesterday when we did the one on the right? It has to slow down, right?
It's momentum and the momentum slow.
Is it momentum?
It doesn't instantly change direction.
Exactly. Very good. So now, does it start right at 0?
Yeah.
A ball is thrown up in the air.
Oh my God.
Where is it? Right down to the ground?
You can start down there.
Okay, well then it would be like this, wouldn't it? Right? Is that what you had? And it says 10 seconds later, so I guess if you want to do a little bit of numerical labeling, that would be 10 right there, right?
Oh yeah.
What would you expect the middle to be at right here?
10 minutes.
5. Although the fact that it didn't start right at 0, would that change that 5 at all? Alex? He's talking to his mom right now.
Alex.
Would that change that 5 at all?
Oh, a whole bunch.
A little bit, right? I mean, depending on how far up it was, kind of thing. Okay. How many people got that one? Did you get it? That's a pretty easy one. Hopefully you got it. Okay, now the next one's really, really hard.
Wait, I thought it was 2 humps because he throws it again.
Does it say that?
Yes.
Where does it say that?
Never mind.
Number 2, what if position were measured in the above example in the horizontal plane? In other words, I'm not measuring how high, I'm measuring, now look at this time as well.
1 second.
I'm measuring how far away. If I throw it up, let me get the ball up.
Don't break it. I can juggle, can I show you? No!
If how far away from it is me? How far away from the ball is it? How far away from me is the ball? My arm's length. Where's my frame of reference? Where's my origin?
Your stomach.
Probably my body. Most people would say that when they make that 0, right? So when I throw it up, and where does it, how far away does it end up? Pretty much exactly the same. What's it going to look like? What's the Nate? Listen. How far away does it change at all? If my body is at 0, I heard Mitch say, is it just a straight line? Yeah, that's what it is. That's exactly what it is. How come? Because it's like 75 centimeters away, and it never changes. It's 75 centimeters the entire trip. It never changes. That's a hard one.
Unless there's wind resistance.
There's a wind to blow it.
Yeah.
Then that's not wind resistance. All right. Number 3, a man walks for 8 minutes from his home on Main Street North, way up there by the courthouse, to the Royal Bank. He spends 2 minutes at the ATM and then returns home. He's walking south. Where is the origin in this
Down.
It doesn't say, does it? How many people use home as origin? Most people do. If you use home as origin and he walks south, then the displacement time graph has to be where? He's walking from home, that's 0, and he's walking south, which is south of origin.
Straight line.
Would it be a straight line?
Stops at the ATM, 2
Would,
minutes.
hang on, before he stops, would it be a straight line?
Yeah.
Most people walk at a fairly constant speed. There might be little slowdowns as he stops for vehicles or, stuff like that. Would he slow down when he gets to the ATM? More or less. But I mean, he's not going very fast in the first place. So I mean, really, it's going to be just a slight little curve like that.
We just kept walking into the wall.
That's going to take 8 minutes. He stays at the ATM for 2 minutes, which takes me to 10. Would he walk faster or slower or likely the same speed back home?
Probably a little faster
Because he's got money in his pocket? Yeah? Maybe slower because his mass has increased. Maybe he took out, took $200 worth of quarters.
He's going to get a Delta, so he runs home.
That could be too. Any of those are valid observations. Now, how many people said that the bank was the origin? One person?
I guess
Okay, well then, as a group, if the bank was the origin, if the bank was 0, what would the graph look like?
Two. It would be reflecting. Flat for 2 minutes.
Would it not just be, whoops, I got several parts apparently. Would it not just be like this? Why not? He is
yeah.
at his home, he walks to the origin, and he stops, and then he goes back. Notice that the shape is exactly the same.
It went the other way.
One way or another.
Thank you, Blind. Pointer. Number 4, a bowling ball spends 8 minutes in the rack waiting to be thrown. It takes 4 seconds for the ball to reach the pins, and then 20 seconds to return to the rack. Here's another one where you have to decide where the origin is. How many people said the rack at the front is the origin?
Yeah.
Most people do. I didn't say north or south, did I?
No.
What are you going to do?
North.
Make an assumption that towards the pins is positive. That's perfectly valid. Your choice. So, they sit for 8 minutes waiting. Doody, just sitting there waiting. Then finally someone picks it up and throws it towards the pins. It takes
4 seconds.
4 seconds, which means the graph is,
Going very fast.
what is that? How do I show that? Going very fast. Almost straight up?
Almost
Yeah.
straight up.
Not a curve.
Not a curve, but straight line.
Tiny bit.
Like that?
Maybe
Well, maybe not that long.
I suppose. There might be a smidge at the start, yeah. But more or less it's straight up like that. And then it returns.
20 seconds.
So how do I draw that? Why is Lucas telling us number?
Last of the curve.
Less of a slant?
There.
Not slanty enough.
Okay, does that look like?
Number 5, a girl leaves her locker by the office and starts to walk to the gym. She walks 15 meters before realizing she forgot her gym clothes. She returns her locker, gets the clothes, proceeds to the gym. Again, you have to make a decision. Where's the origin? Locker or gym? Most people pick locker because that's where you start, right? That's what people do. So, is it positive or negative? We don't know. Doesn't say. In Dauphin here in our school, I guess if you're by the office and you're walking that way, that would technically be south. Technically, it would be negative. I'm not going to get too excited.
We're going to go positive today.
Okay? So, walks 15 meters. Constant speed, what does it look like?
Alright.
Like that. Stops and goes, oh, forgot my gym clothes.
You gotta go
Straight down.
Same speed or faster?
Oh, she has to stop though.
You ran that.
Slow down, he slows down and then
Doesn't say anything about slowing down.
or stop.
Oh, and I realized the locker. I thought
Well, if you want her to slow down, there's a little bit of a, right? Back to the locker.
we have a creeper.
Takes a few seconds to get her stuff out, and then
distracting us.
Mr. Burnett has it. Nate, what's the last little bit look like? Up only to there? How far do I go? farther. If I was marking that on a test, would there be a deduction if you didn't go past the original spot? Absolutely.
Jim's like 30 meters, that's like 15 meters.
Has she gone back to her locker? I would say no. Because she has to go back to where she started. She's like,
An arm's length.
okay.
What do you mean the top?
I mean question A. Let's have a look at question A. I'm going to have to draw it here.
I'm confused.
Okay. What is happening in the first 2 seconds?
Moving 2 meters. Right.
2 forward,
And
1 back.
2 steps forward, 1 step back.
2 forward.
2 steps forward, 1 step back.
I'm not familiar with that song. 2 steps forward, 1 step back. How many meters has the cart traveled at point A?
6 meters. 6 meters.
It went 2, and then 1 is 3,
Negative 1.
1 back.
1, and then to 5, and then another 4, right? So it's 2, 1, 4.
Holy.
Did it not go a total of 7?
No. Because it's negative. There's a negative.
It says, how far,
Doesn't
where is
matter.
it? How far has it traveled? It does matter. Because we're talking about distance. I went 1, 2,
We had it.
don't erase, 3, Josh, 4, 5, 6, 7. I traveled a total distance of 7 meters. That, my friends, is called the distance. Distance is a scalar. We are not talking direction here. Okay, Alex, seriously. 7 meters is the distance, okay? Now in the next question, how far is the cart from the starting point when it's at point A? That is known as the displacement,
5 meters.
and that one is,
5 meters.
yes, 5 meters, and that's known as the displacement, which is a vector quantity. There is a difference. Make sure you know the difference.
I got all 3 of those right. Yeah, I got it right too. I'm excited. No big deal. It's like there's a big deal or anything.
Good for you. What's happening from A to B?
Nothing. Stop.
Nothing. It's stopped.
2 whole seconds.
How can you tell it stopped?
The
The line is flat.
It's a straight line.
How far is the cart from the starting point? Oh no, hang on, number 5. How many meters does the cart go altogether? Well, we've already gone 7, and then we go from 5 down to -3, so that's 7, and then 8 more, and then back up to -2, and then another +1. I get 16 meters total. Is that what you got? Right? Because you go 2 forward, 1 back, 4 forward is 7.
So then the negatives you have to count in
We're talking distance. We're talking your speedometer on your car. Well, maybe that's a bad example, because did you know if you go backwards in your car, it actually goes backwards? It does that. That's a legal thing, by the way. Don't do that.
Not well. You like reverse.
You can't put your vehicle on like a roller and run it in reverse for like
You can.
200,000. Well, you can, but it's illegal. Right? If you back up in a parking lot for a meter, no one's
Yeah,
gonna.
it's not illegal.
No big deal, right?
Like you could like take like 100,000 kilometers.
You could. You'd burn a lot of gas and you'd end up in jail.
Yeah, I got 19.
Did I do the math right? Is it 16? Yeah? I really want to finish this, you guys.
How do you get that?
Yeah, 'cause the choices.
It's 10 down? We're going from 5 down to -3. Is 8, isn't it?
Yeah, 8.
Okay. And then plus 1 more, isn't it?
Plus 2.
Goes from -3 to -2, doesn't it? It's 1 there, isn't it?
So what are the 6s?
Am I right?
Yeah, so the 6s.
But the what?
I'm not for sure.
Okay, number 6. How far is the cart from the starting point when it gets to the end of the trip at point C?
-2.
Yeah, exactly. What is this called? This is the
We're talking about cars.
total distance. And this one would be the
Also, placement.
total displacement. Exactly.
I didn't know the formula.
That's okay. What is the cart's average speed? Speed is the scalar version. So we're talking 16/8. The average speed is 2. Does that make sense? There are some people in here that aren't paying attention and will get that wrong on the handed assignment really soon because they won't have been listening. It is meters per second, is it not? Yeah. What is the cart's average velocity? That's going to be -2/8. Why -2? Because velocity is displacement over time. And so that's going to be -0.25. Please note the difference between distance and displacement and average speed and average velocity. Please note the difference.
It's an average distance over time.
Are you ready for the bottom one? It's pretty easy. Let's just do it. A student leaves the doorway of the physics class from his origin. She walks down the hall, stops for 3 seconds, and then walks back to class. The total distance traveled is 20 meters, and the total time of the trip is 11 seconds. Make a position time graph to illustrate the motion. The total time is 11 seconds. So it ends at 11 seconds. She ends up back at the class, right?
Oh, yeah.
If she stops for 3 seconds, how much time does she actually spend walking?
8.
Right? So 11 minus 3, she spends 8 walking. We can only assume that she walks just as fast forward as she does coming back. So in other words, 4 and 4. So she walks 4 seconds, stops for 3, that takes you to 7, and then comes back. How far does she go? The total distance traveled is 20, so that this stop thing right here should be at 10, is it not?
I got it right.
Of course you did. You're a smart guy. Okay. I'm done yakking. You should be able to complete the front side of this by the end of the next 15 to 18 minutes. Okay? You may not have enough room on there. I would actually suggest you use this as scrap paper and then do like a draft version and then a good copy. It's a little bit challenging. I want you to hand this, to get out of the room at 3:30, I want this front page handed in. Okay, I want a good attempt at this. I'm going to check it. I'm going to mark it. Yes, I am.